Hello to everyone. Let's start with data science. And I'm asking you to type, if you can hear and see, please type in chat. Thank you. And I'm asking you to switch on your cameras if you can. All right, so we're starting, and I'm going to tell you something about data science. My name is Mikhail Poruchikov, but if you want, you call me just Michael or Mike. And firstly, I'd like to tell you about myself. I graduated from Samara University, and I got 2 degrees, one in biosystems and second degree in management. And I worked at many organizations in different roles. So you can see my career experience on this slide. And I worked in a medical organization, in governmental, in the university. And now I'm working for Sberbank of Russia. And my position is auditor. And you can see my responsibilities at the bottom of the slides. So actually, I work with data science on a daily basis. And I'd like to tell you a bit about Sberbank of Russia, or about organization I currently work for. It is the largest and the oldest Russian bank. It was established almost 200 years ago, and it has 100 million customers in Russia. It represented in 20 countries. You can see the number of employees. It's really a large bank. And it is number 18 in the world by market capitalization. So this is about my organization. And I'm asking you to tell a couple of words about you. So I'm interested to know which country are you from, where are you learning right now, what is your major, and what is about your future job. You can switch on microphone and tell by voice on, or you can type in chat. Guys, I'm asking you to take part in discussion because sometimes I will ask you some questions and I will need your feedback. And also, if you have some questions, please ask me and don't hesitate to do this. Okay, thank you. So we have participants from Bolivia, from Indonesia. Okay, so three participants are going to work with financial data and business. Oh, that is very interesting. Event management, accounting, market analyst. Okay, so market analyst, I think it's very close to data science. Okay, we have participants from Germany. John, please could you explain what is HCI? Oh, human-computer interaction. Oh, it's very trending area, I think. Okay, so thank you for your feedback. It is very interesting to discover when you're studying and when you are going to work in. So let's continue. So you know that actually we already live in a kind of digital world, and in every industry and every service we have problems that requires some data processing. And in healthcare, we would like to detect disease as early as possible. We would like to increase diagnosis accuracy, and you can read some examples of problems we're having today. And you know that the world largest companies in transportation are like Uber and Lyft, and they would like to move customers faster and decrease cost, and so on. So actually, we can't now live without computer science, and we have a lot of data in every company and in every industry, and we would like to use this data to make our business more efficient and to make our customers more happy. So we have some classical problems that relate to processing data, and these problems are to predict something, and actually it's a regression problem. Sometimes we want to classify some cases, and that is a classification problem. Sometimes we want to detect outliers or some interesting cases that we would like to discover. And this is called anomaly detection. And for example, in banking, the detection of outliers, anomaly detection is very important task, because we want to discover, for example, fraud transactions. Sometimes we want to find similar groups, for example, similar groups of customers, and this is actually clustering of data. Sometimes we want to predict future behavior, and this is time series analysis. And sometimes we want to compare two situations, and this is usually called A/B testing, and this is refers to statistical test. And I'll show you a couple of examples and to explain a bit in details each problem. So I think that data science actually is an intersection of these three areas. The first area is math, and what I mean by math, I mean basic mathematical calculations, and also linear algebra, and operating with vectors and matrices, and for sure mathematical statistics. So the second area is computer science, and in computer science there are, I think, three important topics. The first is algorithms, second is programming, I mean programming and using computer languages, and third is dealing with databases. And the third main area is domain knowledge. So if I work in bank, I should understand at least basic processes in bank, how to deal with customers, what kind of financial transactions are there, and so on. So if we, for example, we're trying to apply data science in healthcare, so we should have basic knowledge in healthcare. So this is domain knowledge, and it is very important. And this is a question for you. So I mentioned programming before, so I'd like to ask you, could you program? And which programming languages do you know? So that's the first question is basic. So if you can write a program on some language, so please type in chat. Or you heard about some computer language, please type in chat. Okay, then oh, I'm waiting for you. Okay, Python. SQL, Java, Python, R, Python. Okay, a couple of comments from me. Python is one of the most popular computer languages at the moment, and I think it is in top 3 with Java. So SQL, and actually I don't think that SQL is a programming language because we use it to manipulate with data. So actually it doesn't include some constructions like loops, for example. SQL is called language, but it's not a programming language, I think. R language is used by statisticians, yes. So thank you. And I just want to show you what is my experience in languages. So I started with basic with very popular about 30 years ago. Then you see that it was at Pascal and Object, Pascal C, Perl, PHP, MATLAB, and Python. And this is my sequence of languages. Okay, so probably you've heard about some of these languages. So, for example, C is still one of the most popular languages, and it is used to make very fast programs. PHP is used for as a constructor for websites, for example, and MATLAB is used by statisticians as well. Okay, so let's continue. So a short overview of problems I've mentioned before. So what is a regression problem? So imagine that we want to predict how much some house can cost. And actually we use some data set, and we can find data on house area and house prices on the internet, for example, and we could plot this data as points on this graph, and we can, for example, plot a straight line along these points, and actually we can make a prediction of how much can house with a particular area price. How much will it cost? Actually, this is a regression problem. And the second type of problem is classification. So imagine we're trying to predict if we receive a spam email or not spam email. And we can base, for example, on 2 features: the number of words in email and the email size in bytes or kilobytes. And when we get new email, we can predict if it's spam or not. So this is a classification problem, and the number of possible answers in classification is limited, is always limited. The third type of the problem is anomaly detection. This is an example exactly from banking and financial services. So you can see that there are 2 features: average purchases per week and purchases this week. And usually and normally data are focused or concentrated in some area, and if we see some point outside this area or far from other points, then we may conclude that this is a kind of outlier, and we can explore this transaction in detail. Probably this is a fraud transaction. The next type of problem is time series analysis. So it's important that we deal with time data. So actually it's a sequence. And if we have data like this, we would like to predict what will happen in the future. So this data set is from 1950 to 1960, and probably in 1960 we would like to predict what will happen in 1970. This is time series analysis with specific methods and specific problems. The next one is A/B testing. So imagine that we have we develop some mobile application and we want to choose the best design for it. And what can we do? We can show the one kind of interface to one group of users, and that's, let's say, A, and interface B to another users. So you may see that there's a difference between these two interfaces. This is a button, and here it is on the right, and here it is on the center. And after this, we can log, we can collect events that users are generating. We analyze this data, and we can make a prediction on which interface to use, which is most used by our customers. So this is A/B testing. And another interesting area is code process mining. So I've never heard about process mining a month ago. So this is very interesting. It was invented not far away, not a long ago. And so what is the idea? The idea is that we expect that process will go in particular way, but usually we always have the situations when process is executed in other way. So like pedestrians in cities do. So we want them to go on paved road, but they want to save distance and choose another route. So this is a problem, and this is a solution. So the idea is that we can analyze event logs and explore how the process is how the process really works, and after that we can make so we detect some differences and make decisions what to make in this process to make it more efficient. So this is process mining. And now let's talk about data types. So usually generally we can have data of different types. We can have numeric data, we can have categorical data, we have text, images, videos, and probably recordings of speech. So there are many data types. And it's important to distinguish all these data types because usually they are processed in a different fashion. So here are examples of numeric and real data types. For example, weight or price. This is real numeric data. And when we can count something, for example, we count number of people in some room, this is integer type. And in most data sets, we have categorical data. And you know that there are three types of categorical data: ordinal, nominal, and binary. And for example, ordinal, what is ordinal data? So when we can't for example, add this data and multiply, but the order of data makes sense. For example, examination mark, like A blue, A plus, A minus, B, C. So the order is meaningful. That's why it's an ordinal data. We have also nominal data, like color, for example, yellow, green, or red. So there can't be any order, and this is nominal data. And the third data is binary. And the typical answer is true or false, yes or no. For example, is person sick now? Sickness, true or false, yes or no. So the two possible options. And sometimes we have text data. So if you, for example, scan some document, you will have a huge amount of words. We usually deal with images, with videos, and recordings. I won't go explain in details, but in my work, I deal with images and audio recordings daily, and it's very important for me. And another question for you. So here you can see six features, and your task is to say what is the data type for car brand, for car top speed, and so on. And there are two questions, there are two data that actually hard to explain, and there are possible options. So let's discuss car brand. What do you think? What is the data type for car brand? I will return to the previous slide. The car brand, for example, you have car Volvo, Toyota, Suzuki, and so on. So please think, what is the data type for car brand? Now please type in chat what do you think. We're having two answers only. Is there any other idea on data type besides nominal and categorical? Okay, so to understand what is the data type, we should think what values can be. So actually, it's a list of car brands, and obviously, it's not a numeric; it's a categorical. But what is it's obviously categorical, but what kind of categorical data is this? So I think the order doesn't matter here, and that's why it's nominal. So I think it's nominal. And let's go to the second one, car top speed. What do you think about data type? So, okay, let's type the car speed, what is the uh, usual car top speed? So I will type 2. I think this is the value for my car. Okay, and this is we have a correct answer in chat, so it's a real data type because it can have it is continuous. It can have any value actually. So, for example, it can be something like 150.5. So possibly there is a car with this top speed. So this is a numeric, real numeric data type. And what is about the third one? Actually, it's a hard question, but you should think about it. So the location of building. What is data type? If it is hard for you, then try to think how we can write building location. Okay, a couple of examples. And for example, the main building of Samara University can be located by its address. So it will be city of Samara, Moskovskое шоссе. Yes, this is one option. So we can locate building by address. And the second option is we have a good answer in chat. Actually, we can locate any object on the Earth by longitude and latitude. So the longitude approximately for this building will be 53.0, and very approximate coordinates, but actually that's 2 questions are possible. And in a data set we can see two types of locating the building. Okay, so let's go further. Time. How to represent time? What do you think? Actually, it's not easy to represent time. So let's think about possible values. And let's type what is your local time. And for example, in Samara, there's 16:59. What is local time in your location, in your city? Please type in chat. Okay, so actually, like the location, the time can be represented in 2 different formats, and one option is like we typed in chat as a set of numbers when we write hour, minute, second, and the second type of representation is a real number actually. And for example, do you work with Excel? It's a popular spreadsheet. So please type yes or no. I mean, Microsoft Excel spreadsheet. Do you have an experience of working with Excel? Well, sure, it's the most popular spreadsheet in the world, I think. So in Excel, the date and time values represented in a specific way. So days, so if I type something like this, 1.5, let's say it's a bit option, I think. But let's talk about time. So if I write something like this, it will mean that it is actually 12. It is midday. So actually, it's a part of the day. So, for example, 0.75 will mean, so it's a 3/4 of the day. So it will be 8 p.m. 6 p.m. Sorry. So we have two types of representations time. And let's go to the next one. We discussed location of building. What about building material? So what do you think? How to represent material that building is constructed of? Let's do another survey. So I live in a building what is made of bricks. So you're now situated somewhere. So if you're in some building, so what is the construction material for your building? Okay, so I think we can get an answer to this question. What do you think about data type for building material? I would say that building material can be represented as a nominal data type. When I say text data type, I mean that there is a number of words. So text is a phrase. It's not a single word, and that's why, in my opinion, it's a nominal. It's not ordinal because order in this case doesn't matter. And we can say that brick is better than wood or concrete is better than brick. It's impossible to compare them. And that's why it's a nominal data type. And the last question is about outside temperature. And one more survey. What is the temperature in your location? So I think it's about 26 centigrades in Samara. Okay, so what is the data type for outside temperature? I agree. I think this is a real data type. But one note: if you would ask someone what he or she feel about temperature, and if the answer was, for example, it's hot or it's cold or it's normal, but I will type it in chat. Cold, normal, or warm, for example. So in this case, we would have an ordinal data type with 3 possible options, and here the order matters. So this is my answers, just to compare. So let's go next. And when we build some data science system, data science tool, they usually we go through some steps, and here are the general pipeline. So pipeline means some like conveyor, so steps that have to be executed in a particular order. So usually we start with collecting data, then we pre-processing data. Pre-processing means some additional preparation, because usually we can't build any model on the collected data. That's why we need pre-processing. After building a model, we have to validate model. We have to make sure that our model works perfectly. And after that, we make prediction, and after that, we make conclusion. So actually, we're solving some business task, and we're going from data to conclusion. And this is an example of a data set. So what do we have here? We have an information on houses. So we have, let's count how many rows. I think about 20 rows and about 10 columns. So the number of columns is always fixed. And if we have another new example of or instance of data, then we will add rows. So this table is growing to the bottom. It will never expand to the right. And so what we have here, the right column. So if our task is to predict the price, then the right column, sale price, will be target variable. So if we want to predict sale price, the sale price is a target variable. Or in case of classification problem, we would call that that column label. So this is a regression problem. That's why we just call the target. And other columns are called features or explanatory variables. And here we have some information about houses. Lot area, street, alley, year, foundation, the material of foundation, areas, number of bedrooms, year of the garage was built, and places for cars in garage. So actually here we can see every data types we discussed before. So we have a numeric, we have ordinal, we have nominal data here. And also we have very interesting rows. You can see that we have some empty cells, and that's a huge problem. And actually, we can't directly process tables with empty cells, and there are some specific methods how to deal with this problem. So what kind of preprocessing is usually used? So for numeric values, sometimes we use numeric values directly, but sometimes the model we use on the next step will require that data have the same scale. And let's get back. So we have, you can see that lot area 5,000, 21,000, and whereas the number of bedrooms is pretty small. So compare these numbers. Some models can process the data in different scale. That's why we usually rescale all numeric values to the same scale, to the same range. For example, to the range from 0 to 1. The next problem is with categorical features. We also can't use categorical features directly because actually any model deal with numbers, and we have to change the representation for the categorical variables. So we should encode each value. For example, for the street, actually it's a coating, paved gravel road. So we have to encode with numbers somehow, and we will process every categorical variable that we see here. Text data is one more challenging thing in data science. So imagine that we have one more column here. For example, some description of the house. So it's very important to use all data from dataset, and that's why we will encode this text data, and the example will be later. The next problem is missed data or missed values. So we have a lot of missed values here, and the first idea is to just delete rows when we see empty cells. But if we delete rows with empty cells, that we will lose half of this table or more, or even more than half. And this is not recommended. We should do something else, but we can't just delete data because we can lose a lot of very important information. And one of the approaches here is to fill missed values with some other values. For numeric data, we could use, for example, average. So for example, for this column, year of in which the garage was built. So we could, for example, calculate average value on given data and fill empty cells with this average value. And we can do something like this for categorical data, but we can't calculate average of categorical, but we can, for example, count the most frequent items. And let's count gravel: 1, 2, 3, 4. Okay, 1, 2, so 4. So it's a very hard case. We have the same number for paved and gravel road, but actually in practice we usually use the most frequent value here to fill the missed, to fill empty spaces, empty cells, excuse me. And for example, if we have image as a data, we usually will resize images to some standard size. For example, to 224 by 224. It's a very frequent resolution for image processing. And example of preprocessing text. Let's explore this example. We have two phrases. Is there a cat? And the second, this cat is brave. So how to use this data in our model? And the most well-known example approach is to use bag of words model and count frequencies. What it means. So actually, we built a dictionary of all words from these two texts, from these two phrases, and we count how many words are there in each phrase. So it looks like this. So, is this a cat is brave? This is our dictionary, and it consists of 6 words. Every word we see in our text, we write here. And after that, we just count the words. Is this a cat? So there's no words is and brave in the first phrase. That's why we put zeros here. Now the same would do for the second line. So this is a very simple approach. Hope it's clear to understand. And the next is the question for you. It's more complicated. So you can see 4 lines of text here, 4 phrases, and your task is to build the matrix like this and to count dictionary length. So your answer is number of words in our dictionary. So hope you have a paper and a pencil with you. So this is a short question for you. Please do it yourself. Actually, you can calculate words without paper. And I'm waiting for your answer in chat. Okay, the previous slide. So one more time about the idea. We build a table like this, and we just write in here unique words. And then we count how many words in each phrase. I have to return to the next slide because here we have our source text. Okay, so ask the question if you have any. So here all unique words. Hope I didn't mistake here. I can walk, run, have lots of fun, then sing, do most anything. So here are all words, and we should write these words as a header of the table. And then we go through the phrases and count the word numbers. For the first phrase, the word I, we can see 2 times, can 2 times as well, 1 time for walk and run, and the other will be zeros, and so on. Actually, this is an answer in chat. So we have 13 unique words, and this is the length of our dictionary. So I think I can show you the answer. And I hope you will get something like this. So here our dictionary, and here we calculate the number of words that we see in each phrase. And please type in chat if you understand what is on the slide and what if you understand the idea. So yes or no, if you understand, please type yes. If you don't understand and I should explain it, then type no. I need your feedback. So actually, if we do this type of preprocessing for text data, we can feed our model with these numbers. Actually, we switched from text representation to representation in numbers, and we can build any model, actually. But this is a very simple approach because it doesn't consider the sequence of words. We just count the numbers. And let's compare two phrases. This is a cat and is this a cat? Actually, these are two different phrases because one of them is question. And but here we would get the same representation for both phrases. And this is the advantage of this approach. But there are a lot of more complicated approaches and more precise approaches, but we don't discuss it now. So this is all about texts. Let's explore this funny slide. So I've already mentioned about model validation. So when we build some model, we have to make sure that model is working correctly. And in other case, we will get something like this. So actually, we shouldn't make the prediction like this for the situation on the slide. But some people don't validate models, and they can get something like this. It's on the other hand, on the one hand, it's funny, but on the other hand, it can cause a lot of problems for business. So let's continue. And I'd like to show you a couple of examples from computer vision from image processing. So this is a problem of face detection and how to detect people, for example, on this image. And the one approach is to detect faces. And here we solve this problem. But actually, if you look carefully at the picture, you can see that we detected faces where there are no faces in this situation, for example. And the other problem is that we didn't detect faces when there are faces in this situation, for example. So actually, any model makes mistakes. There are no completely precise model. And there are a lot of metrics that allow us to make conclusion how good our model is. Next example. This is an example of image classification. So the task is to detect what is on the image. And here we have 3 predictions. So actually the model that was used here is trained to detect 1,000 different objects. And here we have a top 3 predictions for this image. And the numbers here are probabilities. So the model thinks it's a trolley bus. And this was made with neural networks. And for sure, you've heard about neural networks. I will type in chat. Neural networks is a very powerful class of machine learning models that mostly used to process image and to solve problem like this, for example, to classify images. And the second example of using neural networks is another problem. The problem is called object detection and localization. It's a more complicated problem than previous, and here you can see that the model recognized 3 objects on this image and spotted the areas with these objects. So they detected car, bicycle, and dog. And it is very interesting that we couldn't solve this problem just about 10 years ago. And we can solve it because of because there was a huge growth in neural networks performance during last years, and we can solve the complicated problems like this. And sometimes the models solve the problems like this better than people. And this is very interesting. And the last example of application of neural networks to image processing. The technique is called neural style transfer. and probably you've seen examples. So let's imagine we have two pictures, and the pictures on top is a photograph taken on the embankment of Volga River in Samara, and the second image is a painting by famous Russian painter Marc Chagall. And what if we take the style from the second image and apply to the first image? So we can get something like this. So the content is derived from the first, and the style is derived from the second. And here's the combination. And this problem is solved by a special kind of neural network as well. And oh, this is my favorite example. So computer people sometimes do some funny things. So this was made in this year, and you can explore these videos by yourself after this lecture. And there was a very popular group in about 30 years ago called Земляне, with very popular song, and the people of Generation X and older perfectly knows this song. So what some guys did, they took that video, they took the photo of Elon Musk, and they actually, you see what they did. They substituted the original face by the group leader with the face of Elon Musk. So this is very interesting because this is made with video, with not statical image, but with video, and it looks very natural. And I recommend you to compare those videos. John, could you explain your first questions? Yes, there we know VGG16 and ResNet, but actually, if the question, if there are other types of neural networks, yes, they are. And I'll type the mobile net is a specific network architecture that can be applied and even on mobile devices. So it's fast and it still have perfect performance. And you know that technology allows humankind to do a very interesting thing. And you know that there are projects of self-driving cars, for example, and you know that now cars can drive without a driver. We have some problems with this. The technology is not that good, but it is developing. And when humankind invents engineering solutions like self-driving car, we always should think about ethics. And this is a very interesting thing to think about. So probably you've heard about the problem described here. It is called trolley car problem. I hope I didn't make a mistake. So it is about ethics and about making decisions. So what we see on this slide. So we have a trolley that moves in the forward direction. And it can kill 5 people if it moves forward. And we can switch direction to the right. And in this case, the trolley will kill just 1 people. So if you could switch the direction, what would you choose? You should not give an answer because it's very hard. But we should think about a situation like this. If we do nothing in this situation, then we kill 5 people. If we do something, we kill 1 people. So the question is about making decision. And when we invent self-driving cars, we should program their behavior. What should self-driving car do in this situation? It's very hard to make decision here. So just remember that there's ethical problems with artificial intelligence, and we should care about the problems like this. So let's switch to the typical toolbox of data scientists. I'm going to show you what tools I use. Daily. So the programming language is Python. You mentioned this language earlier in chat, and actually this is #1 language in data science. And here the list of libraries for Python I usually use. So I will describe it shortly. So the basic libraries are NumPy, SciPy for linear algebra and scientific computing. When we deal with data represented as tables, we usually use pandas. When we build models, for example, for regression, for classification, or for neural networks, we use sklearn and keras. Actually, many people use other library than keras when applying neural networks. When we want to plot some diagrams, I usually use matplotlib and seaborn. When I want to get some data from websites, I use these 3 libraries. For text processing, RE and PyMorphy. So I will describe in details what they can do. For image processing, OpenCV, and for audio processing, 2 libraries, PyAudioAnalysis and Boston. Data science brings many interesting things in our lives, and it can do many useful, but there are also some bottlenecks. And one bottleneck is about disappearing jobs. And you can read this tweet by Andrew Ng. Andrew Ng is one of the most known data scientists in the world. So you're studying at the university, so probably you know that scientists measure their performance with H-index, Hirsch index. So the H-index of this guy is more than 100. It's like a god for us. So the image processing is so powerful nowadays. So it can make predictions on diagnosis better than average doctor, and it may cause the situation in which doctors will lose their jobs, and it is a very important challenge for the humankind. So, shortly about impact of data science. So, it gives us a lot of new opportunities, so we can get better service and personalization of services. So, if you watch YouTube, then YouTube gives us a prediction on what we like, and shows the video that we could probably watch, we probably want to watch. So if you order some goods on the internet platforms like AliExpress, then the platform will show goods that probably you want to buy. But also we have some threats. And I mentioned one threat, disappearing jobs. The second problem is that now it becomes hard to distinguish between real and fake content. So you've seen the video with Elon Musk. So if you didn't see original video, you probably see that processed video is real, but actually it's fake. So, and it becomes hard to distinguish between real and fake news and real and fake content on social media. And the power of artificial intelligence makes it makes hard for people to distinguish real and fake. And we discussed a bit the ethical problems that come from data science and from artificial intelligence, like a trolley problem, and that's a trending application of the recent year was deep nude. So you can imagine what this technology can do. So, and now I think it's all about the review of data science, and I'd like to show you some examples of how to use Python and libraries to predict department price, to collect data from website. I'd like to show you the Kaggle platform. Kaggle is a platform for data scientists when data scientists can compete and win some prize. And if we have time at the end, I will show you how to manipulate data from scratch. So if you have any question, please ask me right now. Okay, so let's go to the first demonstration, and I will switch from the presentation from the slides to another page. So hope it will work. And now we should see another web page. So please let me know if you can see this page. Please type in chat. Okay. So this is example of predicting apartment price. So this is actually a Python script, and I will explain what I'm doing here. So usually, at first stage, we are loading libraries we need in the script. So NumPy, Pandas, Seaborn, and sklearn were mentioned before. So all these libraries are used here. And the second stage is loading data, and let's look what on our data set. So this is again about apartments, not about houses, but about apartments. So I collected this data about this data set about 2 years ago from the website, and we have some information about apartments in Samara. We have a latitude, a longitude, area in square meters, floor, number of floors in the house type, this word. So you probably don't speak Russian, but this means that this house is made of bricks. Kitchen area, and none means that actually we don't know kitchen area for this apartment. Actually, it's an empty cell. There's a problem of empty cells here, of missed values. Living area, number of rooms, and apartments with one room. It's a text description, we don't have here, and final price. So we would like to predict price, and let's look at the data set. Another part of the data set. So what can we do else? We can, for example, draw the diagram like this. So you know that I use only one feature from this data set. I use only total area, and I don't use another features. Actually, for real model, this is very bad because I lose a lot of information. But for demonstration purposes, I just use another feature. And you can see how the price and total area are related together. Excuse me. And what can we do the next? We will preprocess data, but actually I will delete rows when I don't know the total area or price. This is prohibited in real models, but here I will do that. And after that, we just build a simple model, simple linear model. And these are predictions that model, and those red points are predictions that model do. It's a very simple linear model. That's why all predictions are situated on the same straight line. And after that, we can make a prediction. So imagine that we want to predict how much two apartments with area of, for example, 50 meters and 300 square meters will cost. And we'll substitute the area to the model, and we get prediction. And about 3 million rubles and about 22 million rubles. So we can check it on the diagram. So for 300, we will have about 22, something here. So this is a very simple example of regression problem. And so I'd like to return to presentation. Okay, so another problem is about collecting data. One minute, please. Okay, you should now see the folder on my computer. Can you see it? Please type in chat if you see the folder. There should have been some files in this folder. Oh, guys, I need your feedback because I can't see what you're seeing. Okay, so let's go to the demonstration itself. And you should see another demonstration. Hope you see it. So this is a demonstration of collecting data from a website. So the problem is sometimes we don't have data represented in a table or in some database, and we have to collect data by our own hands. And what we're doing in this case, we will do something like this. Firstly, we load libraries, and so the problem is to collect information about employees of Samara University. And how to do this? You can do this manually. You can list through the web pages of the website, but you can write a script on Python and collect in this data in automatic mode. What this program do? This program scans the site of Samara University and extracts information about employees. And there are about, as I remember, 1,000 employees in the university, but we collect information about some of them. So here's our data set. It's at the top of our table. And after that, oh, sorry. So after that, we can, for example, collect the pictures for each person. So what this application do? It extracts avatar for each employee and puts it on the folder. And that's why I asked you to say if you can see my folder, because now it will filled with images. So let's try to look at the folder again. Oh, I can do it another way. 1 minute, please. So this is pictures we just collected. So there are names of some employees, and we collected about 15 pictures right now. So this is about collecting data. And the next example about Kaggle competitions. And I just want to show you how it looks like. And we will go to another window. Please let me know if you can see this window. Okay, so I took part in different competitions, and so let's explore what can we see here. And so, for example, this competition, instance C questions classification. So the task was to analyze a huge data set of text and detect which of the texts are sincere and which are not. And I just want to show you code. And let's see this example. So it is again code written on Python, and here we use the same libraries I've explained before. So we use the approach of counting words, of building dictionary, and so on. And actually, the approach used here is quite simple, but it allowed me to be in top 30% in the leaderboard, and this is funny. Not so much. It didn't took much time, but the result is really great. So the same pipeline. First, we read data. We vectorize texts. We build model for classification. So here I explored some metric for classification. And this is not important now, but actually, you know that there's no much lines of code here. It's pretty compact program, so but it allowed to get pretty high score in this competition. So this is Kaggle. So if you're interested in data science, probably you know this platform. And if you're going to get a job in data analysis, I recommend you to sign in for this platform and take part in competitions. And the last example. So I'm going to write some code on Python from scratch, from the blank screen, but I will need your help. Hope you will help me. So I will need data from you. So I'm going to show the typical data manipulation techniques I usually use. And I want to prepare data with your help. So I think that we will build a small database, and I'm asking you to type one more time. Type in chat, please. I will write here. How I didn't demonstrate my screen, so okay, you should see the screen right now. So please type name one more time, country, university, and major. And we will build a small database and use it in the next step. So please do it in one message. So type all features in one message: name, country, university, and major. And actually now I opened, you cannot see that, but I opened Notepad and I enter data you type in chat right there. And then one row about me. Okay, so now I'm saving the file in Notepad, and we will work in my script. Okay, so first we're importing library called pandas. And now we can read our table we've just built before together. Oh, this is it. So we can load our data set. So what can we do? Let's, for example, compute the dimensions of the data set. And the command for this is df shape. So we have 6 rows and 4 columns. Let's do something more interesting. Let's count how many people are there from other country, from every country. So we will type something like this: df group by. Some syntax, sometimes syntax looks like the syntax in SQL. Oh. We have some problems. Houston, we have a problem. Okay, let's skip this step. Let's do something else. Let's, for example, arrange the data. We'll sort this data set in particular order. So we have some problem. I can't understand what is happening actually. Let's do something else. This comment shows information about the data set. And we have another method to discover information that is called describe. Describe. And what this comment do, so you can see that it shows the number of each value and the number of unique values, the number of the most frequent values. Okay, let's do another thing. Let's, for example, show the people from a particular country. Or, for example, from Malaysia. Oh, the same mistake, the same error. Oh, this is a big fail for me. So I'm so sorry that I can't demonstrate it to you. Okay, so I think this experiment was not that successful. I'm so sorry again, but let's stop this experiment. Okay, so I think actually this is all for the review of data science. And here are my contacts. So one more again, my name is Mikhail Poruchikov. I work for Sberbank in Russia, and please stay in touch. This is my contacts on LinkedIn, on Facebook, and also there's my email. So thank you for watching. Excuse me for my fail at the last step of the lecture. So, and it was great to see you here, and please take care and be safe and stay in touch, and hope to see you offline. So thank you and bye.